All right. I think I'm recording now. Sorry about that. Recording, yeah. All right, good catch. Sorry about that. All right, so I am recording now. And so the idea, it should be recording now. Yeah. All right. Okay, great. So we are recording now. So anyway, as I was saying, I'm introducing the topic of unsupervised learning. The difference between unsupervised learning and supervised learning is really that in unsupervised learning, you have no labels, right? So whereas in supervised learning, as what you guys have seen in the class, we have X and Y. Here, we only have X, no Y. Nobody took the time to annotate. You guys understand why. It's really, you did all those examples with Twitter. It was very easy to download tweets, kind of convert them into feature vectors, etc. But it wasn't so straightforward to annotate it, right? You have to sit down and put labels on it. You probably did it like happy or sad or iPhone or whatever. And so it takes a lot of resources. So most of the data in the world obviously will not be labeled, right? Will not be labeled. And so it's unsupervised. So then what are the things that you could do with unsupervised? Like I said, there's a lot of things actually that, you know, so there are topics that would be covered in 530 class, like autoencoders, word embeddings, etc., things like that. But in this course in 520, I'm only going to cover 2 applications of unsupervised learning. One of them is, as I said, something called clustering, and one of them is something called dimensionality reduction, both of which are pretty useful. So and so that's basically the idea. So we're gonna, we're just gonna jump into the code, and then after that, I'm going to explain it a little bit more. But the first thing we're going to do is we're going to learn how to do clustering. Okay, so we're going to learn how to do clustering. I'm just going to go into the code. You can see here in the thing that you downloaded. Well, actually, it's not here. So we have to go to, I'm going to open up the browser. Okay, and I'm going to go to the GitHub. Okay, and in the GitHub, we are going to look for sklearn. All right, and actually, we're just going to look at this script clustering, so you can just download it. All right, that way we don't have to type it up or anything. The code should just be there. We may just need to modify it a little bit. All right, so this should have downloaded to the downloads here somewhere. Okay, downloads, and then all right, here we go. So as you can see, there's quite a lot of topics. We're only going to focus on this one, clustering, so that we can take a look at it. So I'm going to just copy this script to the desktop, 520. The data for this one will just be created automatically. All right, so we're just going to create the data automatically, similar to what we did in the XOR problem. So that's usually the best way. So I'm going to open up the terminal emulator now. All right, so I'm in the terminal emulator. Make that bigger. All right, so I'm going to navigate into desktop, ITS 520. All right, so now basically the clustering script. All right, so as you can see here, you know, the libraries are sklearn. From sklearn, we can use data sets. There's a module there, make blobs, which would help us to just create random data. Then we have from sklearn clustering, we're going to import an algorithm called KMeans. Keep in mind, this one KMeans is not the same as KNN. All right, so KNN is for supervised learning. Whereas KMeans is for unsupervised learning. Okay, so KMeans is unsupervised, KNN is supervised. Okay. Then, you know, matplotlib again to plot, and then numpy, you know, to create numpys. So here we can see, let me just comment out this. So pretty much until here. All right, you can see here I have, you know, we're going to be doing some plotting because certainly in unsupervised learning, plotting is useful. And then I can see there's some print statements there that need some modification. But let's just go with this for now. So let me just run it. So basically the idea here is that we would create some data, X and Y data, right? For now, make blobs. We're going to create 200 samples or, you know, some other value with 2 features. And we're going to define that it should have 6 centers or 3 centers. And then we establish what the cluster should be, the standard deviation and so on of it. All right, so let's go ahead and run that. Oh, and I need to do bash here. Okay, and then we can use, shouldn't matter which one we use, given that it is just sklearn actually, but since these have the libraries, should be useful. All right, so okay, so now let's just run it and see what happens. So I anticipate a few little errors, so so if you spot them, let me know for sure. All right, so that print done, I knew that was going to error. Oops, what happened? Nope. Okay, so let's change that print statement to Python 3. All right, so now Control X, Y. All right, so it printed done. So I'm assuming it created the data correctly. All right, so then, as I said, this would basically create X and Y data following 200 samples with only 2 features. Remember, if it has 2 features, we can plot it. If it has 3, we can plot it. If it has 4 or more, we cannot plot it unless we either slice only 2 or 3 features from the entire feature set, or if we do data compression. So let's then try to plot this now. So we're going to create a scatter plot of X, right? Where we take all the samples on each axis from 0 to 1, and then we just provide the markers, size, etc., print and show. So let's see what the data looks like. Okay, and there's no data there. Okay. Here's X. Okay, a little bit better. So if you guys look at this figure, you're intelligent. You're advanced AIs, right? Well, except you're not AIs, you're natural intelligence. So if you look at these, how many islands or groups or whatever would you say are on that picture?
6.
6, right? 6. So there are, in fact, 6 clusters there. However, you are very intelligent. And so you look at this and immediately you have pattern recognition that solves that for you. However, an algorithm, a computer is as good as its algorithm. So obviously, the computer can't just say, I look at this and I see 4 clusters. It has to use an algorithm, right? And so there's an algorithm. So without us getting into the details of the algorithm, I've already introduced it. It's called K-means, right? So the K-means algorithm would basically then look at each one of these samples, use this algorithm of K-means, and then basically assign to each one of these little red dots a different color based on the cluster they belong to. So if I say 6 clusters, then hopefully, if K-means is really good, what should it do? It should take the ones in this cluster and make them all one color. The ones in this color, in this cluster, make them into the color. The ones in this cluster, make them into the color. It'd be interesting what it does with this point. It's kind of on the fence. I would think this point becomes part of this cluster. This is a cluster, this is a cluster, and that's a cluster. So that's the idea with K-means. Remember that every one of these dots is a sample, right? This would be the X0, this is the X1, and so those points are used to plot the sample there. Okay, so that's pretty important. Okay, so what did I do with that graph? All right, went away. I don't know where it went. Oh, there it is. Okay. All right, so I think it went away. All right, so that's basically the idea, okay? So we created the cluster, we plotted it. Now our goal will be to take each one of those points and use the K-means algorithm to plot them, all right? So that's gonna be in this code over here, as you can see. Now we're gonna say, you know, we're gonna use K-means. One thing that you can do in K-means is that you can assign what are called centroids. So it's basically you can randomly pick two, let's say 2 points, right? 2 points. If we want 2 clusters. So if we want 2 clusters, we can provide 2 points there and just pick these values at random within the range of the values that we have. And that way it allows us, just like I've said before many times, right? Where you initialize your algorithm is really important. So in this case, we're just going to initialize a centroid at 8 and 7 and another centroid at 2 and 8. And that's just initial centroids. After that, the algorithm will take care of, actually finding the more correct centroids. So you can see we can provide the centroids. We can provide those randomly as well. And you can see that here. So here I have, or we have, the K-means algorithm now. Notice it's called not KNN, but KM for K-means. I'm going to say that I want 2 clusters. I can provide initial centroids, or I can say random so that it figures it out on its own. Then I'm going to say an initialization value that it's going to use, right? N in it. And then max iteration is the 300 iterations that you're going to perform in this algorithm. So it's like a for loop of 300 and some additional parameters like a tolerance, random state, etc. Right? Some values. You can just leave these as default. All right. Once you do that, you've set the parameters for the clustering algorithm. Then you can do KM, which is this model over here, KM, right? And you're now going to do fit and predict. Fit and predict. So you're going to take the X data, all those red dots that we just saw, and you're going to generate a new YKM. Notice that initially when we created the blobs, we had a Y, right? So all those clusters that we created 6 of them, they already had assigned labels, right? So not only did it create them in the shape that we saw, but we also had a vector that reflected, that there were 6 groups and where each one of those samples belonged. So now what we're going to do is we're going to train K-means to look at the data, try to build 2 clusters, right? 2 clusters, and assign to each one of the red dots to be in one of the 2 clusters, basically, right? So that's why this is a vector. This is a vector, and we can print it out here. It's going to be a vector of, I think it's 200 samples that we have. How many samples do we have? Yeah, 200. So 200 samples will be printed out, and I can get rid of this. All right, and just put comment here. All right, so now that's it. That's the K-means algorithm. Okay, so now we can just go ahead and run it. All right, there's the plot. And there you go. You see that the K-means did its job and it assigned labels. So this is a way of that you can create from data that doesn't have labels. You can still say, you know what, I want, I want, 6 clusters, 2 clusters, whatever. And then it's going to group things into clusters and then show you, zeros and ones there, right? So each red dot now belongs to one of the 2 clusters. Does this make sense, guys? Are there any questions about this idea? No questions? All right. All right, so if there are no questions, then we can continue. So now that we've done the assignment, that's really all you need. You really don't need to visualize it usually. You just need those labels to know where each sample belongs. But given that it's a simple data set with only 2 features, we can actually go ahead and just plot it. All right, so that we can see how it works. So we can see here, we do a scatter plot. So we've got labels are 0, labels are 1, and this one actually has for 3 labels. So this would be, so the way this is structured would be for 3. Clusters. So then, so I don't have to change that code. Might be easier just to go here. And I'm going to say I want actually 3 clusters, 3. And instead of assigning these things, I'm just going to say init equal random. All right, and add a comma there. Okay, so hopefully that should work. That should give me 3 clusters, and then I should be able to plot it if everything is correct. Light blue, orange, and light green. All right, so okay, so let's try this out. Okay, so there's our data initially. There's Y, the Y, and then now it's the graph. What do you guys notice about this? What do you see? Do you remember the 6 original little clusters? 1, 2, 3, 4, 5, 6. You see that, right? Except that now it did 3 clusters because that's what we asked it to, which makes sense. It did these 2, this one, and then these little red stars are the centroids that it created for us. So as you can see, you know, this allows you to play with the data and see the results. So the K-means algorithm group things, and we can actually visualize it. Although usually you would just want to play around with the you would only need this information here. So you would only need the YKM, which is the predicted labels, but here this allows us to plot the clusters. If you wanted to do the 6, for instance, if you wanted to do the 6 clusters, you would have to add here 3 more of these, right? Because we only did, so let's say you want 6, right? You want 6 over here. So let's try the 6. So I'm going to do 6 here. And then this is random. Guys, can you hear me?
We can hear you.
All right, thanks. So my computer froze. That's why I asked. All right, so I'm creating 6 clusters here, right? And then that means that for viewing, I would have to add 3 here. So I'm going to copy these 3. Copy. And then oops. Okay. And then I'm going to hit paste. Okay. So that should have 6 now. So we just have to modify them a little bit. So this should be the first one, plot scatter, light green. We're going to have to pick different colors. Cluster 1, cluster 2. Wait. 1, 2. So this one would have to be then, this one would 0, 1, 2. So this would have to be 3. And this would have to be 3. This would have to be 4. This would have to be 4. And this would have to be 5. This would have to be 5. And then we need to change the colors. Light green, orange, light blue. All right, so just say red, purple, do we use yellow? It's probably too light. Black maybe. All right, so we just need to try some of these. We can also change the name. So this would be cluster 6, cluster 5. Oh, wait. Cluster 4. All right, so, you know, hopefully this will work. So I've modified the plot. I want 6 clusters now. So if everything is correct, this should run. Okay. So there's the original data. And there you have it. What do you guys think? So it created 6 clusters, 1 purple, 2. See, look at this. It made these 2 into 1 cluster. And then this is 3. This is 4. And here, these 2 are 5 and 6. Do you guys see that? So it actually, the K-means algorithm didn't exactly do what a human would do, which is basically this should have been a cluster and these should have been 2. So let's try it again. Maybe if we choose another set of random values, we could get those 6. Nope, still the same. All right. So anyway, that's the algorithm. Suggestions for this might be to just try different starting points, different randomization maybe. Yeah, it's still doing that. So this is where the algorithm, you have to play with the algorithm a little bit and try to figure out. So maybe if we did more iterations, let's try this as 10 instead of just 1. So I'm just playing with the parameters of the algorithm here. Ah, there you go. Much better, right? So different parameters now give us yellow, black, light blue, purple, red, and light green. So now we have the 6 clusters, and the K-means algorithm performed better than before. Any questions, guys? And that concludes, so this is unsupervised learning, the K-means algorithm. Okay, so this is just a K-means algorithm. Okay, so that's the K-means algorithm. Now, what we're going to do is I'm just going to leave a couple of minutes for questions. If there are no questions, we are done with K-means, which is one example of how to do unsupervised learning. Remember, the key thing here is it's not so much the plots, but the fact that the algorithm gives you these labels. Okay, it gives you these labels here. And then what you can do is you can compare these labels to the original labels, right? The original Y labels. But by the plots, we can pretty much tell that they're almost the same. But you can always just compare them. And if you know, that would give you the error basically. But in this case, you would never really have Ys anyway. And so, but as you can see, the algorithm did find ways to plot basically our data. And so we were able to get these 6 made into, you know, everyone has been assigned the label. So these would be assigned label 0, label 1, label 2, label 3, label 4, and label 5. All right, so so as far as unsupervised learning, this is the first topic, which is K-means. Okay, so that is that topic. And then after that, the next topic related to unsupervised learning is data compression. And so we will cover that in the next video. So are there any questions at this time? No question?
Professor, I think I have, this homework is due today or it's end of the semester?
Right.
Professor?
Yes, that's right. That's what I said. Yes.
Okay, can you hear me? I'm asking actually the Kara's homework. It's not due today, right? It's just you put the date, the 30th we will discuss, but it
That's
due
right.
1 hour by the end of semester, right?
Right. That's what we did were you at the beginning of the class? That's what we did, right? So I opened it up to questions and students asked questions. You see that?
Right, but when is the due date?
The end of the semester.
Okay, thank you. That's all I want to know.
Last day of class. Any other questions? So my question to you guys is unsupervised learning clear at this time? Guys, any questions about this topic, or can we stop the video here and move in, you know, we'll take a 10-minute break and then start the next topic. Is everything clear enough that we can move on? All right, I'm going to assume that it's okay. All right, so we're going to stop this video here and unsupervised learning. Okay, we're going to stop it here, and we'll be back in 10 minutes. So it's 3:28. So we'll be back at 3:38 for the next topic in unsupervised learning, which is what Joshua had brought up. You know, how do we plot data? So, you know, we'll talk a little bit about, I'll give you the code for data compression, and then you guys should be able to apply it to your Kara's homework. All right, so I'll see you guys in 10 minutes.